Welcome to the beginning of chapter 6. My gosh, but some of this, as we begin chapter 6, is going to be a review. And I know that you're excited about reviews because this will give you a chance to show me how much you remembered from chapter 2. Now, as you remember, there are several rules that we had. We're just going to start putting them together a little bit more interestingly, I guess is the better word, maybe a better adjective or adverb. Here we go. These are the two basic rules we introduced you to in chapter 2. Now, they are going to play an important role, especially when we multiply and divide polynomials, which is where we're moving to. Now, as you remember, the rules are in this column, and then I have some examples to make sure that your brain remembers. One of which is the product rule. We are adding the exponents, but remember, the bases must be the same. In the power rule, we have a piggyback relationship, which means we're multiplying. Then we had a couple more rules. This is giving me a term. We have to remember that in the term, there are exponents. That 9 has a power of 1. That t inside has a power of 1. And then we're going to use the distributive property to get 9 squared, t squared, which will give me 81, because 9 times 9, and t squared. Then we had the fraction. Again, the powers of the terms inside the parentheses, in this case, had a power of 1. Well, we are then going to distribute to the numerator and the denominator. That's why we get 2 to the 5th, r to the 5th, and remember, 2 to the 5th is 32. Then the beautiful part is anything to the 0 power is 1. Now, we also had negative exponents, and this is where you gotta be careful. This r in example 1 has a -2. You have to remember that that r has a positive 1 below it when it has that -2 power, and then we're flipping the base of that -2, which becomes 1 over r, and it's just like our rules in the past. This was our fraction rule. We get 1 over r squared. Now, the easy part about the second rule is that you'll notice this fraction has two different bases. It has a base of a to a -m. It has a base of b to a -n. We're going to flip the fraction. That's the easiest way to do it, rather than do it the long way. And then we make the exponent of a -3 the same. Okay? And then we had where we have a fraction with a negative power, the base flips to make it a positive power. Now, the quotient rule in this is talking about the fact that m, which is the numerator, is greater than the exponent in the denominator. Now, there's one other rule that for some reason got cut off. If m is less than n. That's a different rule. That's saying if 2 to the 4th is over 2, here, is got 2 to the 9th. This is this rule. This is saying I have a 1, but it's 2 to the positive 5. Okay? This rule pertains when m is bigger than n. When m is less than n, you're going to have a 1 in the numerator. Don't forget that. Okay. Now, we're going to do a couple of slides using some review just to help you. Now, right off, what's inside the parentheses is to the power of 0, which means 5/3 to the 0 is 1, plus 1/4 to the 0 is 1, which gives me my first problem of 2 as my answer. Now, problem number 2. Remember, that 4 is got a 1 underneath it, and I have this negative exponent. The first thing I'm going to do is flip the base of the exponent that has -3, and it becomes a +3, which is going to give us 1 over 4 cubed, or 1 over 64. The base of a negative exponent flips. Okay. The base of a negative exponent is going to flip, and that makes the exponent positive. Now remember, each of these is going to give me 3 squared over 2 squared, because this exponent is multiplying by the exponents of the base term, which is going to give me 9 over 4 as my final answer. Now, be careful with this one. This -2 has 6 as its base, not a negative. That negative is not going to be considered. This is going to give me a -1/6 to the +2. 1/6 to the +2, which means I have a negative. This negative has nothing to do with the -2. It is not the base of the exponent, which is going to give me 1 over 36. Huh? Watch out. Add 2 negative to the negative. And then we have these two. Okay, well, this is really nice. F is -1, G is -5. The easy way to do it is to flip where F and G occur. F is in the denominator. It makes a power of +1. We just flip the fractions. If it's in the denominator, it goes to the numerator. If it's in the numerator, it goes to the denominator. Now, number 6, we have numbers. Well, the numbers are multiplying. 3 times 5 is 15. But these are going together. But I have 2 b's and 1 b in another, which gives me a total of 15b to the 8. Okay. Okay. Getting a little more interesting here. Okay. Now, if you look at problem number 7, the negatives are inside a parentheses. So that means we're going to take the -2 and we're going to add these exponents, which is 9. This is going to give me a -2 to the 5th. Well, this is where this is considered the m and the n. M is greater than n from that negative. So what I have is -2 to the +4 power. I quotient rule, I subtract. And this will give me very nicely a +16. Okay. Now, number 8, I have numbers. When I have numbers, the fraction reduces, which is 1 over 2. 4/8 become 1/2. Now, I only have 1 y cubed. That's in the numerator. So it is staying wherever it's at. Now, if you look at the z's, my power of z in the numerator is greater than the power of the z in the denominator, which means I'm using my quotient rule to subtract. Now, sometimes this 1, remember, that's a number that mathematicians don't always write. This should be y cubed m cubed with just the 2 in the bottom. Okay. Oh, why did I write m? Should be z. I can't spell, or I can't read, one of the two. Okay. Ha 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 ha. So, because I was thinking of the m being bigger. Well, that is my lovely answer. Now, here's one more slide to help you remember everything we did from chapter 2. Okay, first off, negative exponent. This is going to flip, which gives me 9 v to the 5th, w to the 9th, to the power of 2. Let me make that a better 9. Okay. Well, piggyback rule. This 9 has a power of 1 in the numerator. So that means 9 squared is 81. This 2 is multiplying by the 5. And this 2 is multiplying by the 9. This is my answer. Okay. Now, this 3 is only pertaining to what's inside the parentheses. It has nothing to do with 3a. Now, that means -2 to the power of 1, piggyback rule, -2 cubed. Now the a is multiplying. 3 times 2 is 6. But this 2, -2 cubed, is a -8. That -8 multiplies by 3 to give me 24. But don't forget, I have an a here, and I have 6 a's here, which means that I am getting a to the 7th back here. Now, these slides should hopefully help you remember what we did in Chapter 2 and what we're going to need as we move through the polynomial world. Hope this helps. Bye-bye.